The origin of life on Earth is one of our greatest mysteries. Could life on Earth have originated elsewhere from our universe? Could the comets that brought water to Earth have also brought the bacteria that evolved into the rich variety of life we see around us today? Panspermia is a radical theory that was first proposed by the ancient Greeks. It suggests that life can spread from planet to planet in our universe and could mean that our ancestry traces back to an as-yet undiscovered world. The theory suggests that tiny microbes or bacteria can become embedded in rocky debris, which is then ejected into space following collisions between planets, asteroids, and comets. These asteroids and comets can then travel to other habitable worlds, crash land on the surface, and kickstart the evolution of life once more. Panspermia is certainly not a proven process and not widely accepted by the scientific community. But with thousands of distant planets now detected in our galaxy, the hunt is on to detect a signal of life from one of these distant worlds. I'd like to take you on a short journey today, exploring how life may be much more widespread than previously thought, and how life may regenerate to populate the universe. For many years, the ingredients for life have been discovered inside rocks orbiting the solar system and inside some rocks that have crash-landed on Earth. These ingredients are formed of the same elements as life on Earth, elements like carbon, nitrogen, oxygen, hydrogen. In 1969, a meteorite landed in Australia called the Murchison meteorite. Several studies since then have found the evidence for amino acids, the building blocks for proteins and DNA, buried within fragments of this meteorite. Another study was conducted last year that found more evidence of complex organic matter within fragments of this meteorite. In 2014, the European Space Agency's Philae lander probe surveyed a distant comet in our solar system called Comet 67P. As it was orbiting the comet, it detected the signs of organic matter in the atmosphere around the comet. Just before it touched down on the surface of the comet, it sent its signals back to Earth, reporting that the majority of the comet was formed of water ice with a thin layer of dust around the outside. In 1990, a meteorite fell in Algeria. Just last year, a team in America reported the first ever detection of a long, complex protein inside a fragment of this meteorite. This is the first ever complex protein detected inside a meteorite ever. The findings of these chemicals inside rocks in our solar system suggest that they could be responsible for transferring matter across our solar system. But could these rocks also transmit life around our solar system, or even further afield? How far would life have to travel between planets, and what is the chance of it surviving such a brutal trip? Well, space is a pretty inhospitable place. You won't find many 5-star reviews on TripAdvisor for outer space. The launch is pretty harsh. You've got to survive the intense vacuum and radiation of your journey, and then the landing at the other end is almost as harsh. What kind of life forms could survive such a journey? Could life forms have began life elsewhere and traveled towards Earth? For panspermia to have any scientific merit, we need proof that life can survive these types of extreme journeys. And we know of several life forms that can indeed survive such a journey. One of the cutest animals that can survive in outer space is a tiny microanimal called a tardigrade, also known as a water bear. These are tiny, microscopic, 8-legged animals discovered about 150 years ago. These animals can survive extreme conditions here on Earth, the hottest temperatures, the coldest temperatures, the highest pressures at the bottom of the ocean, and they can even survive in the vacuum of space. Despite being known as water bears, they can actually survive for decades without any water at all, in a state of suspended animation. Many years ago, hundreds of tardigrades, or water bears, were flown into orbit around Earth for 12 days, mounted to the outside of a rocket, a pretty uncomfortable trip. This would have killed any other animal, but not the humble tardigrade. Most of them survived completely unharmed and unfazed. Just this year, more tardigrades, water bears, were launched to the International Space Station to investigate how their genomes may help them survive the harsh conditions of outer space. Whilst the water bears are perhaps the cutest animals that could survive in outer space, it's much more likely that tiny microscopic bacteria are the passengers responsible for spreading life in our universe. The most interesting type of bacteria that could survive this trip is called Deinococcus radiodurans. This is an extremophile bacteria. You can put it in any harsh conditions you like, and most of them will survive. In addition to surviving in extreme temperatures and pressures, they have a special skill. They can withstand intense bursts of radiation, like the kind they experience in outer space, and they can automatically repair their own DNA, a feature not yet found in any other life forms. Many of these bacteria were launched onto the International Space Station this year as part of a Japanese space agency program called Tanpopo. Tanpopo is the Japanese word for dandelion, and the word dandelion was chosen for the experiment because it was thought that the seeds of the dandelion drifting through space resembled the seeds of life spreading throughout our galaxy. Well, what happened to these bacteria on the space station? They were exposed to the harshness of space for 1, 2, and 3 years. The vast majority of them survived by using a thin layer of dead bacteria, almost like an umbrella, to protect the colony beneath from the harmful radiation. So we know that these bacteria can survive for at least 3 years. But scientists think that in fact they can survive long enough to travel between any 2 locations in the solar system. Certainly from Earth to Mars, to Venus, to the moons of Saturn or the moons of Jupiter. But instead of bacteria traveling from Earth to another location, what about bacteria that's traveled from another location to Earth? Well, we may all have Martian ancestry, and it may not be just the men who are from Mars. Hundreds of rocks on Earth have been traced back to the red planet via their chemical composition. Just this year, NASA's Perseverance rover touched down in the Jezero crater on Mars. The rover is looking for signs of life in addition to surveying the Martian climate and the Martian geology. We think that Mars was once a very habitable world, full of liquid water, stable, warm temperature, and a thick atmosphere. The Jezero crater itself, where the rover is currently, was once a large lake with its own river system. The rover is looking for signs either that life once existed on Mars billions of years ago or is still there, buried beneath the surface. If life did exist on Mars, perhaps it all died out after the evaporation of the Martian atmosphere. But perhaps it survived by going underground, later being transported to Earth via Panspermia. Such a trip from Mars to Earth would take a couple of years, not too long on the cosmic scale. Again, the bacteria would have to withstand the intense pressures of being launched into space following a collision, the intense radiation and the vacuum of space, and then the harsh landing at the other end. And we know that bacteria can, in theory, survive this trip. But what about a longer journey? Our Milky Way galaxy could be exchanging life across vast distances. This depends on a number of factors, including the distance between the stars and the planets, how fast the comets or the asteroids are traveling, how much material gets ejected into space after a collision, and of course how long the organisms can survive for. The most likely place to find this kind of interstellar panspermia is in clusters of stars, really dense groups of stars. And we find several of these within our own Milky Way galaxy. If we're looking for panspermia anywhere, these are the locations that we might find it. We have evidence for these longer distance transits within the last few years. In 2017, a small rocky object named Oumuamua, which I believe is Hawaiian for traveler, was found entering our solar system. It passed our sun, passed the planets, and returned to the cold, dark space between the stars. In 2019, another small rocky object was detected entering our solar system. A small comet, a few kilometers wide, nicknamed Borisov. These two objects could not have been created within our own solar system. They're moving far too fast, around 200,000 kilometers per hour. They must have come from a different star system. Comet Borisov came probably from a relatively close red dwarf star system named Kruger 60. It began life as an icy remnant orbiting around its home star, came slightly too close to another planet or a comet, was ejected out of its orbit and traveled and accelerated towards our own solar system. This journey could have taken millions of years, but we think some bacteria could survive this trip by going into a state of hibernation and coming back into life at the opposite end. We need more evidence if we're going to believe any such crazy theory. There are currently 2 probes investigating whether the theory of panspermia could be true. The NASA probe OSIRIS-REx and the Japanese craft Hayabusa 2 are currently orbiting the solar system looking for more evidence of organic matter in distant asteroids and comets. And they may return more evidence that our solar system really is littered with the ingredients for life itself. Panspermia is quite a novel theory, and again, it's not widely accepted in the scientific community. But if it is responsible for spreading life around our cosmos, there may be a huge number of life forms out there waiting to be discovered. Depending on who you are and what you believe, some people think that life is rare and can only form here on Earth. Some people believe that life can form on any planet given the right conditions, entirely independently. But some people believe that life can all form from the same primordial seed scattered across the galaxy via panspermia. I wonder how that might change the opinion here on Earth if we discovered distant life on another planet. Well, with thousands of habitable planets now detected, many of which full of liquid water, the hunt is on to be the first to detect a signal of life from one of these distant worlds. I wonder how that might change things on Earth. It's amazing to think that the story of life on Earth, many billions of years in the making, could have begun with our distant ancestors on a faraway planet a long, long way away. Thank you.